Hi all, welcome, welcome. Come on in, find a seat. We'll start in about a minute. Welcome, welcome, welcome. Get started here shortly. Thanks for joining us. Okay, it is noon Pacific Standard Time, so we'll get started on time again today. My name is Alan Barr, and on behalf of the NIOSH-supported education and research centers throughout the country, we're pleased to present another installment of the 2020 ERC Ergonomics webinar series, offering free monthly webinars on various topics on human factors and ergonomics. This collaborative effort on behalf of each ERC's continuing education program aspires to provide access to current research supported through NIOSH ERC programs. So thank you for joining us today. Little housekeeping before we move forward. We do have another ERC webinar on ergonomics coming up October 21st, 2020 at noon Pacific Standard Time. Minnesota's Safe Patient Handling Act, Policy, Practice, and Research in partnership with Midwest Center for Occupational Health and Safety, ERC. And again, that's October 21st. All participants logging in today with their registration email will receive a link to the recording and an evaluation form that will qualify you for a certificate of completion worth 1 continuing education contact hour. You will be muted during the presentation today. If you'd like to ask a question, please enter into the online Q&A. We'll save some time at the end to address your questions. As I mentioned, the webinar will be recorded and it will be made available with past webinars on our COEH Northern California YouTube channel. If you like the content, please like and subscribe to help us continue to grow our channel. Today's webinar, the title of which is Seat Bolster Design and Discomfort in Agricultural Equipment. It's presented by Mr. Matthew Hutmacher, a NIOSH trainee and a master's student in industrial engineering, in partnership with North Carolina OSHERC, UNC Chapel Hill, North Carolina State University. The presentation will examine discomfort related to the design of seat bolsters in agricultural machinery and the scope of an upcoming research study on this topic. And this is an underserved segment with little research quantifying the impact of seat bolsters. And our speaker today is Mr. Matthew Hutmacher. Mr. Hutmacher graduated from North Carolina State University with a bachelor's in science in industrial engineering in December of 2018. He's currently a NIOSH trainee and a master's student in industrial engineering, studying human systems in engineering at North Carolina State University. His interest in agricultural machinery and seating is derived from an internship with John Deere and their ergonomics staff. And with that, it's my pleasure to hand the mic over to Mr. Hutmacher. Matt, it's all you, Matt.
All right. Well, thanks for having me on to kind of talk about my research for a little bit here. And as I said, my name is Matt Hutmacher. I'm an MS student at NC State University in the industrial engineering department. And the thesis research I've been pursuing is kind of to do with seat bolster design and discomfort, particularly in agricultural equipment. So this presentation will be primarily split into 2 larger sections. The introduction, where I'll just kind of go over some of the study overview, just a high level view of what it is and what I'm trying to accomplish. Some justification as why I think this research is valuable, some potential benefits that may be derived out of the research, a little bit of the supporting literature that I found in relation to this topic, and kind of hit on some research questions on, what I think might occur in the research. And I'll also have a methods section where I'll kind of go through some study design, participants, and things like that. So for my study overview, my overarching goal is to be able to define the effects of seat bolster design in agricultural machinery. And kind of an important note here, just to have some context, is what I'm really primarily focusing on are kind of compact tractors as well as riding mowers. So the riding mowers are kind of included in this group for two reasons. The seating shares a lot of similarities with the tractors. A lot of the designs are very similar, and they have some similar posturing, a lot more upright than, say, like a car or some other piece of machinery. So to kind of quantify this relationship, I'm planning to use objective measures, namely pressure mapping, and then some subjective measures, this automotive seating discomfort questionnaire and the Nordic body discomfort questionnaire to evaluate these seats. And kind of the general idea of the study is the participant will sit on a seating rig that I constructed on the pressure map and play farming simulator in different configurations while I collect the pressure map data and then fill out a subjective after each one of the trials. So I figured I'd start out just kind of giving a brief overview of what exactly a seat bolster is. So on the left here, I just took a picture of one of my seats, the high back seat, and in that red rectangle, they're kind of the cushions that come up on the seat pan. And kind of their primary benefit would be considered to be they provide you some security, especially in a tilted or an unstable situation. And then off to the right, I reference this SAE standard, I believe 2732, fairly frequently. And this just kind of gives a definitive answer as to what exactly a bolster is and where the bolster would start and stop. And it's between the top of the bolster would be the W1020, and the start of it would be the W1040, according to that standard. So for my justification, kind of the primary one and kind of where this idea originated is through my work with John Deere. I was doing an unrelated pressure mapping study with some seats that they were looking at on some small machinery. And one of the design engineers I was working with made mention to me that there wasn't really a lot of good, solid ideas, research that defined like what is a good seat bolster, when's too big, when's too aggressive, what kind of machinery you really want a bigger or smaller bolster on. And I kind of took that idea and ran with it for this. And there's kind of supporting that. There's really a general lack of research focused on this, as I'll kind of get into in some following slides. It's just generally not really something that's been touched on a whole lot. And finally, this is what I want to do as well is to define some of the static factors of seat design. So on this figure on the right from Geikis's model of seating discomfort from a book he wrote in 2016, there's a fair amount of research on the dynamic factors of seat design, to do with vibration, long-term use, but there isn't really that much that deals with static factors, and particularly kind of the aspects of like seat shaping and stuff. So that's kind of what I wanted to touch on there and just kind of tap into that a little bit. So in terms of potential benefits, the primary one obviously would be an overall decrease in the seating discomfort in users. I do think an important note here on this point is you would be most likely to see this decrease in not so much like personal private users, people that just own a lawnmower and mow their lawn for like an hour, whatever, once a week, maybe in the summer. I think where you're really going to see it are people either in farming or landscaping where they're going to spend 6-7 hours, long periods of time on these machines. And that kind of gets into some other stuff, which I'll get into a little bit later. But the people that are going to be on the tractor for a long time and be in contact with those bolsters, I think that's really where you're going to see some benefits out of a research study like this. And I think another potential benefit is some decrease for manufacturing costs. If perchance I find that smaller bolsters perform as well as a larger bolster, then I think that you might be able to say cut a little bit of cost, strictly material, just from adopting some lower profile bolsters, which, well, in a singular unit might be a fairly low cost saving over, tens of thousands of units might provide some real benefit. So getting into the literature, I'll start out with some of the agricultural research that was relevant to this. And kind of as I mentioned in that first bullet point there, really what I was looking for was agricultural research that hits on that on this cross section of anthropometry, seat design, and discomfort. And kind of with those three criteria, you get two general research segments. The first of these is research that looks at specific populations' lack of fit. And I have a few papers listed there, referenced there. And really, kind of what this is referring to are, I believe that the three I found were Iranian, Indian, and Brazilian, respectively. But basically, different population groups that maybe the designs based on, maybe a North American model, their population metrics are a little bit different, height, weight, type of things. And that's not terribly relevant to this study. It's really where you get into some stuff that's fairly relevant is the research using pressure mapping to define discomfort in the seating. So there isn't a ton of that out there, and kind of the difference from what I'm doing now is those seem to be a little bit more high level. They'll report the highest pressure located on a seat, but they don't seem as concerned with like kind of trying to dice up that pressure map and figure out what might be attributable to different parts of the seat. In a general pressure mapping, the highest pressure point will always be in the buttocks. That's where you're exerting the most pressure without fail. So kind of my difference here is I took some steps to cut off. So I was only looking at the portions of the pressure maps that were dealing with the bolsters. So I also used a little bit of automotive research as a reference point for this thesis study. And there's a lot of automotive seating research out there. I kind of cut it down to two studies that are relevant for today's presentation. So the first one was Reed's 2000 study. And this it kind of defines how far from the SIP, the seat index point, the bolsters should sit. So Reed suggested that they should sit 250 millimeters to either side of that center line, the SIP, and then back bolsters would sit 280 or 288 millimeters above the seat pan. And actually a study that shares a lot of similarities with this is Filtness's and et al.'s 2014 study that was looking at seating discomfort in police officers. So this kind of the general, well, kind of a high level view of this study was Filtness had officers in full gear come in and sit in different seats and then record what portions of the seat design made them most or caused the most discomfort. And among those, I believe the second or third one was seating bolsters. And actually there is some decent overlap in the subjectives that we use. I believe that Filtness also used the ASDQ, the Automotive Seating Discomfort Questionnaire, and the Nordic Body Discomfort to help evaluate those seats that he was looking at. One thing to note, kind of on the automobile research side of things, is it's not really a perfect parallel for agricultural machinery. And this really kind of comes down to three things that are majorly different between those two types of machines. So the first one would be seating posture, and this is a pretty busy diagram here, but kind of what it's saying is basically cars have you sit kind of at more of an angle where you're a little bit lower profile, and that's obviously because fuel efficiency is important in a car. You want to get it as slim as possible so you can be as aerodynamic as possible, save as much fuel as possible. Whereas in a working machine, particularly a tractor, you really want to be sitting straight up. And this kind of gets into my second point of vision direction, where in a tractor, you're really going to need to be looking around your machine, especially if you have a implement attached. Even just with a mower, on a tractor, it can be front mounted, it can be mounted directly underneath the cab, it can be rear mounted, it can be boom mounted, so it's way off to the side on either side. So you have a lot more variability in having to shift around in your seat, find where your corners are, see what you're doing than you would in a car. And of course, controls are significantly different between those two types of machines. Cars are pretty limited to just steering wheel and pedals, whereas in a tractor you've got innumerable other controls. You got PTO switches, you've got maybe joysticks if you've got a front loader mounted. And I think that could definitely have an impact on how much you're running into those bolsters, how much you're impacting them, how hard you're impacting them, especially if you get into like additional pedals that might not really exist in a car. So kind of the final part of this introductory section is my research questions. So question 1, how much will the seat design bolster or seat bolster size and position affect the pressure distribution? The second one, how do bolster height and size change response variables in people with different anthropometry? Anthropometry primarily being weight, but also gender. How do non-forward facing and flat driving situations affect subjective user discomfort and pressure distributions? And how effectively can pressure rating be used to predict subjective discomfort in users? So in my method section, I'll hit mainly these 3 topics. So participants, kind of what I think might be important for this study, and some of my inclusion criteria. The apparatus, so not only the seating rig, but also the technology and how I set all that up. And then the experimental design, just kind of the different factors and replications and all that fun stuff. So in terms of participants, I think that sex and weight are gonna be the 2 most important factors in participants. So sex really just comes down to bone structure and maybe some fat distribution. But basically, as we can kind of see on the figure here, male hips tend to be a little bit higher and thinner, whereas female hips tend to flare out a little bit more. And especially in lawnmowers, there's a pretty even split between male-female users, just from some of the stuff I have worked on at John Deere. So I think it is really important to be able to effectively characterize both those populations. And then weight's actually a pretty interesting thing, because of course you have hips and your waist are going to be larger with higher amounts of weights, but it also pretty dramatically affects how a pressure map acts. Something that you might not necessarily expect is people that are heavier tend to have lower overall pressure ratings, whereas thinner people have much higher, much hotter spikes. And really what that comes down to is it's a surface area problem, where it's your heavier participants, they've got more area to spread out over, so generally they're lower in pressure. I think age is another potentially important factor. This one probably links in a little bit more with maybe some of my backwards facing and angled portions, but of course, older users are maybe a little bit more prone to discomfort, maybe a little bit more prone to being sore. And I think that there's a potential that people that are a little bit older might more acutely feel the effects of poor or overly aggressive seat bolster design. And I tried to keep my inclusion criteria fairly lenient. I think that it's additionally important to get people with a range of operation experience, people that are complete novices to people that are long-term users. Uh, so really my primary inclusion criteria was I wanted my participants to have some level of experience driving the machine. Though it should be noted here, what with the COVID-19 pandemic, I actually did implement some additional like, COVID specific things, but that's not particularly relevant to this particular presentation. So in terms of apparatus, first I want to just go through some of the technology that I used here. So the simulation I used was just Farming Simulator 19, I believe, running on a PlayStation 4. It's quite simple to use, quite simple to set up. You can kind of customize it to whatever you want it to be, especially if you were going to use a PC version of it. And it allows a really seamless connection with that second point with different control methods. And for this study, just to increase some of the realism, have it more closely mimic some of the postural stuff that I think you would see, I went ahead and bought a steering wheel and pedal set. It is important for this type of research that you get the angles right. So I don't have the steering wheel flat mounted. I do have it up on an angle. But I think that the steering wheel and the simulation combined kind of fairly, well, as faithfully as you can probably get away with in a lab setting, recreate the experience of driving a tractor and doing some sort of task. And finally, the pressure map I used, I believe it was a body track pressure map, high resolution body track pressure map. It's really just a C-pan one, so it's fairly small. And I believe it goes up to 200 millimeters mercury pressure, if I'm not mistaken. So kind of one of the more important things here was creating a relatively faithful recreation of the seating rig. So the seating rig I created was based on a John Deere 100 series lawnmower. And something else that's really quite important to creating a seating rig is you want to make sure that your measurements are right. It's in machinery, operator station design, even 5 millimeters is a really important amount of distance that you have to cover. So being able to get your rig as precise as possible is quite important. So basically where I took all my relevant measures from were the center of the slide rails. If there are any, if ideally how you'd want to do this is if you're working with a company, because this research was not sponsored by John Deere, it's just through our lab, but if you're working with a company, you could get your hands on like seat geometry, machine geometry. Really what you would want to do is measure all your things off the seat index point. That's the most reliable point of measurement, I would say, in reference to the seat. But without that, I just went ahead and used the center of the slide rails. So, and an additional thing on the rig, I also went ahead and installed slide rails on both of the seats, just not only to recreate the interior of a cab, but also so smaller participants, shorter participants, wouldn't have as much trouble reaching the pedals. So I think that's actually a fairly important consideration that you need to make if you were going to do a study in this vein. Okay, so my experimental design, it's a within subject design. I have 8 experimental conditions, which are, well, seats, well, it's the seats, it's the angle, and then it's the forward and backwards facing. And I have 2 replicates of each of the experimental conditions for a total of 16 trials, which kind of come down to 5-minute trials with some short breaks in between them. And you can kind of see the setup I have here. For the angled condition, I have the rig put up on on 4 jacks. And then I have a forward and backward screen that I have an HDMI switch hooked up to, so I can kind of toggle between those 2 easily between the different trials. So for independent variables, I have 3 2-level variables, which I kind of just mentioned. So the first one is the seat. I have on the left there a low back seat, on the right a high back seat. And I think that these 2 represent 2 fairly different ideas on how you should go about seat bolster design. So the low back seat, the bolsters, as you can see, they're a lot less prominent vertically. They're shorter. They're not quite so contoured. But in general, they're somewhat thicker, and they're actually a little bit closer to the center the center of the seat. Whereas the high back, you can kind of see they a lot higher, they're a lot more contoured, and they sit a little bit wider on this seat. So those are 2 fairly common methodologies for the seat bolster design. You might get into some variations if you get into like the really, really small seats or some of the no bolster, just kind of straight bench seats. But in terms of foam seats, this is a pretty typical representation of what you're going to see. And then you get into the next one is rig angle. So the rig angle, basically what I do is I jack up one side of the rig to put it at roughly a 10-degree angle. And this is also something that's kind of been derived from my work at John Deere. Generally, whenever we've been doing live testing of a machine, a mow on slope section is included. And that is kind of this bottom image there where you're mowing kind of across a sloped surface. I think that this is actually, and I should say I've run about 6 participants at this point. So something I've kind of seen borne out so far, just, from looking at the pressure map as it's collecting, is this situation causes a lot more contact and a lot higher pressure values just because it kind of forces you onto them a lot more. So I think this won't necessarily be a huge concern if it's just like a personal user, but especially on something with a golf course or something like a golf course or a farm where there's a lot of hills, maybe in a more hilly region, you might spend a fair amount of time on some sort of side mowing or side harvesting type of activity where you might be on those bolsters a lot. So I think that's a fairly important kind of thing to capture. And finally, I have driver orientation. So as we kind of saw in that previous slide, I have the front mounted screen for forward facing and that rear one, which is kind of over the left shoulder of the user. And really what that's trying to capture is, as I mentioned earlier, you can have implements in a lot of different places, and they vary pretty wildly from how long they are, where you want to be looking, how far, in front of or behind the machine they are. So I think while it's not perfect, because you really, what it kind of boils down to is the user will spend 5 minutes, one of those 5-minute trials facing behind them. And that's not terribly realistic. I mean, really, kind of the behavior you would see would be someone driving forwards, but, frequently checking over their shoulder, but that's difficult to recreate in a lab. But having that captured, I think, will also be important, just because that causes a lot of, shifting in the seat. You kind of have like an awkward posture, trying to keep feet on the pedals, but also not torque your back and neck all the way around to stay comfortable. So I think that this is also something that might bear out some pretty interesting results on how much they're getting into the bolsters and how hard they're getting into the bolsters. All right, so for dependent variables, the first one, as I mentioned, was pressure mapping. So this I do want to talk about a little bit here. So as I mentioned, something that I really wanted to do was to differentiate where the bolsters start and stop and be able to collect the data just on those bolsters. So as you can kind of see on the left image there, this was from Jones's study, or 2017 study, where they used they used an automated process to extract this particular information, but what I ended up using was that SAE 2732 standard and figuring exactly where the bolsters were in relation to that, to a point. The point being, in these seats, the drain holes. And this is something, if you're going to do pressure mapping on a seat, I think is also quite important, is being able to identify an easily locatable and constant area that you're not going to mess up finding is really important. So the drain holes actually fill that fairly admirably, because even through the pressure map, you can kind of feel the indentation. So basically what I do is before each trial, I go through and I find that drain hole and then use that as kind of a location or a central location before the trial starts. So I'm later able to extract the data. And then for the subjective measurement, I have that Automotive Senior Discomfort Questionnaire, which the reason I went with that one is, of the various automotive and agricultural seating discomfort surveys that were out there, this ASDQ was really the only one that specifically looked at the bolsters and specifically asked questions about the bolsters. And I think it's kind of an interesting questionnaire as well, just because as opposed to the second one I'm going to talk about in a second and several other surveys, it actually uses continuous scales to extract this information. And then my second one, the Nordic Body Discomfort Survey, which is, I feel like, a pretty well-known one out there. So basically, this is the image I used for my copy of it. Basically, I just have the body, or this image of the body, kind of sectioned off into multiple sections. And I think that it allows a good opportunity for the user to identify, exactly where, if anywhere, they're getting some discomfort. So kind of my final slide will deal with some future work and some potential weaknesses of the study. So I think that one potential area for some continued work would be on other aspects of seat design. So like I mentioned earlier, there's a fair amount of research when it comes to some of the more active factors, things like vibration particularly. But like I said, there isn't really a lot, not only in bolsters, seat pan bolsters in this case, but seat back bolsters, things like seat stiffness, how stiff the foam or material is. That is kind of an untapped resource, which I think could definitely have uh, applications, well, have some opportunity for future work. Another one that's kind of interesting that's been mentioned to me whenever I've, through my work with John Deere, working with some experts in seating, in ergonomics, is the interaction between foam seats and clothing. So over the past maybe decade, I think that synthetic bottoms, like basketball shorts, like yoga pants, have gotten a lot more popular. And how those interact on strictly like a friction basis with the seats, how much they're catching it, and how much more you're sliding around when compared to jeans or some sort of like cargo shorts, khaki shorts. That might actually be something fairly interesting. That even gets into potentially some safety things, in a side mowing type of application where you might be a little bit more prone, especially if it's bumpy ground. Like how much kind of, yeah, I don't want to say, like how much roughness does the foam surface need to be able to effectively grab even more slick uh, fabrics? And kind of the final one is, would have, I think that this type of research could also benefit from being a field study. This originally was intended to be a a field study, but due to the pandemic and a bunch of other factors, that didn't really kind of end up pulling through. But having the ability to evaluate particular aspects of seat design, but also be able to see some of that active stuff and how that might kind of interplay, I think is actually a fairly interesting, fairly important idea that definitely could use a little bit more work. So that's kind of my spiel. So
All
I'll
right,
take no
Matt.
further questions.
Okay, Matt, thank you very much. At this time, we will open it up to questions. If anyone has a question, feel free to throw it into the chat or the Q&A, whichever you prefer. Let's see, I just got my first question actually. Will there be a future study on the stiffness of the chair's foam types and as it relates to vibration dampening?
I think that's definitely valid. So my intention after this is to go get, well, hopefully get a job. Well, yeah, market as it is. But I do think that's actually pretty worthwhile. I mean, vibration obviously is a problem, especially for long-term users. And I think if you can dampen that through something like the foam, I mean, foam's fairly cheap and you might be able to get a higher density without adding a whole lot of cost to your machine, which is obviously a concern, especially on a smaller machine if you're not having huge margins. So while it's not currently planned, I think it's definitely worthwhile to get into.
Okay, is there much, I know you said that there's not much research on seat bolsters in industrial equipment, but is there much research on industrial seat design in general, and not the bolsters notwithstanding? Has that been looked at?
So there's a decent amount on vibration, and there is some that gets into different types of seat suspensions actually. So things like air ride seats compared to spring-based seats. That actually does have a little bit of research push behind it. But in general, and if you get into automotives, there's a million studies on like big trucking automotive seats. There's a lot out there if you really want to go find it. But
Gotcha.
in terms of agricultural, it's a little bit more limited. Sorry, I cut you off there.
Got you. Someone asks, can private users choose seat pan size to suit their anthropometrics? I wonder if that question is specifically around going out and buying a John Deere ride-on mower. Can you say, since it's your mower, can you order a specific size seat pan? Is that something that that they generally offer?
So, not to my, not particularly like that, probably. But what you could do is generally, I let me make sure I kind of say this right. So it's not a monolith, I guess. It's not like a John Deere tractor or lawnmower is sold and there's only one seat that fits on it, right? You can get a whole bunch of third-party seats, from Milsco, from whoever else. Northern Tool has a million seats. So it's not so much that you can customize your seat bolster with. You could go find something with bigger seat bolsters if you wanted to. But so the short answer is kind of. I mean, you can even, if you're willing to do like a little bit of like jury rigging and kind of like rig up your own or a seat yourself, then you can even further expand your options into something even a little bit more fancy. So kind of.
Gotcha. Do you have any preliminary data insights to share, or still in these early data collection mode?
I will say, like, I don't want to be too exuberant. I haven't really gotten the chance. This is strictly just kind of watching the pressure maps as they're collecting. So take that as you will. I will say there, especially with that forward-facing and rearward-facing conditions, those have much, much different pressure prints. So I still obviously need to analyze that data, but I do think that there is some promise between those two conditions in particular and how different they are.
Got you. So I have a question for you. How important do you think the dynamic component on the drivers, that is to say the accelerations imparted by like a rough terrain, how important do you think that is on bolster design?
I think it's quite important. I mean, I'm fairly new to the business of agricultural seat design, agricultural ergonomics, but just from the little bit I've seen, being out in the field, some farms are not really flat. They're pretty bumpy, they're hilly. So I do think that how much you're going to hit, bumps, rocks, etc., that's going to change how much you're into that bolster. That's going to change how hard you're hitting that bolster. So it is definitely something that I think needs to be looked at, though it does get a little tricky just from a, purely from a study perspective, just because, I mean, how much noise you're getting, if any, from on the pressure map just from the thing vibrating. I can't really say. I haven't put it on a active machine, but I think it would have an effect, maybe a pretty significant effect.
Yeah, it seems intuitive to me that the bolsters really come into play when you get this, this lateral jarring from the stiff suspension, maybe like throwing you sideways, and the bolster offering some resistance to that, some support. Anyway, let me move on to another question for you. Does Nordic or Auto Survey account for heat, that's seat material breathability, contributing to the discomfort reported?
I do not believe so. I don't have the ASDQ in front of me like right this second. The Nordic definitely does, and that's a pretty standard what part of your body hurts and how much does it hurt. I do not believe that the ASDQ has questions specifically on heat. No.
Got you. Let's see here. That study that you brought up about police discomfort, it seemed to me that maybe that the utility belts that officers need to be wearing kind of made that a small specific niche type group of people. What's your feeling on that?
I would tend to agree with that. I actually have a little bit of experience with police belts. I did a study or helped out on a dissertation study that was looking at seatbelt or a utility belt arrangement. And I do think it's fair to say that that's a fairly small segment. But I do wonder a little bit because a lot of it, it's not even necessarily that heavy. It's bulky is the problem. And I do kind of wonder, like, if that bulkiness might have some sort of like some parallel, you know?
Sure. Someone is asking why you wouldn't study max. Let me just read it verbatim for you. So, why are you not studying for maximum accommodation of users for safe driving with respect to anthropometric measures? That's kind of a, I don't know how you feel about that, but you can,
I mean, I guess that I'm not sure how much anthropometry necessary. Well, I guess are we talking safety in like the acute sense or like in the like acute like falling off a tractor or like in the long-term sense? Because I don't really know necessarily how much effect anthropometry is going to have, unless I mean, unless particularly you're talking about like really short users. But that's, I mean, mine's a little bit more in that discomfort. Safety is kind of its own thing, I would say. Like those are almost, those two things don't necessarily talk that much, I don't think, you know?
sure. And a participant's asking about your feelings as a NIOSH trainee. How's that experience for you? And I'm going to close with that question since I have no more in the queue.
Okay.
Can you speak to that a little bit?
Yeah, I would say it's been a pretty positive experience for me. I kind of like the little bit of a general story. I kind of wandered into the ergonomics lab here at NC State on a something of a whim, just looking for some extra experience, and I thought the work was really interesting. And as an undergrad, I believe I was a junior or something. And honestly, it's my professor's been really good. He's given me a lot of free reign on how I want to do my research. I'm funded, which is pretty awesome. And they've given me enough flexibility where I can pursue my own research and also pursue employment, which I've been doing with John Deere, which has been great. You know, it's kind of, it gives me a really nice balance of like you go in, you see something in the classroom, and then you're able to go through and see a real world application of that idea, of that data. And kind of, I think that something that's nice about it is they give you enough flexibility, enough freedom that you can not only learn about the stuff in class, but you can really get out there and apply that if you have the motor or the motivation and the opportunity to do so, which I think is great.
Yeah, that sounds like a great opportunity. Well, I want to thank you very much for your talk. And with that, I'm going to just make some closing comments here. I'd like to let listeners know that you can learn more and register for our upcoming webinars at coeh.berkeley.edu. You can also subscribe to our YouTube channel, where you can find recordings of previous webinars and other events. As a reminder, all participants who logged in with their registration today will receive a link to the evaluation form that will qualify you for a certificate of completion worth 1 continuing education contact hour. So again, I'll say thank you so much to our presenter, Matt, and to everyone who joined us today, and we hope to see you again next time. Be safe, everybody, and we'll see you later.